Hi everyone, welcome back. In this video I'm going to be going through some practice questions to do with composite rectangular prisms. So we're going to be taking a look at the assignment I gave you last class, which was page 32, number 4, 6, 7, and 10. Okay, so let's just get started here. So number 4 tells us that each object has been constructed from centimeter cubes. Okay, so a good starting point is always to create yourself a little legend. Okay, so every single one of these cubes that we see in the image is a centimeter cubed, meaning 1 centimeter by 1 centimeter. That's the dimensions. Length times width will give us the area. 1 times 1 gives us 1. So every single one of these faces is 1 centimeter squared. Okay, so that's my legend right there. Okay, and the reason that I say this is important is because not always will the units in the image that you're given be centimeter, be a single centimeter by a single centimeter. Sometimes it might say that it's constructed from 2 centimeter cubes or 3 centimeter cubes, meaning it's 2 by 2 or 3 by 3. So that's always a good starting point, is just to have this at the top of the question so that you can refer back to it when need be. Okay, so next thing we're going to do is we're going to break it down into the 3 sets of matching views, meaning a front and a back plus a left and a right plus a top and a bottom. Okay, when it comes to the front and back, left and right, I know often students say to me, I don't know which is which. It doesn't matter. Okay, as long as you're not calculating the same faces more than once, it really doesn't matter what you designate what. So I'm just going to call this darker blue shaded region, I'm going to call that my front, and then the one opposite to it will be the back. Okay, so if I imagine that I am looking straight on at that, okay, it's very similar to this model that I made, the little staircase model. Obviously not the same dimensions, but if you imagine looking straight on at this little staircase shape, you just get a rectangle. Okay, and the way we find area of a rectangle is just length times width. And because we're accounting for both the front and the back, whatever I get for the area of the front, I'll double it. Okay, so 2 times, let's take a look at what our length and width would be. So the length right here, 1, 2, 3, 4, 5 units across, and each one, like we said in our legend up here, is just worth a centimeter, so that is 5 centimeters. So 5 by width 1, 2, 3, 4. Okay, notice I'm not counting this diagonal line right here because that's representing the little ledge. That's representing this little ledge. Okay, and what I'm counting is I'm counting this as though I'm looking straight on at it as a flat surface. So that means from this straight on view I would only see the 1, 2, 3, 4 units. So 5 by 4. Okay, so 5 times 4 gives me 20, and then 20 times 2 gives me 40. So that takes care of the area of my front and back all together because I doubled it. Okay, next, left and right. So because I called this dark blue region my front, that means that this little L shape here is going to be my left side. So if I imagine that I'm looking straight on at that left side, I'm going to end up just looking at an L shape. Okay, I'm not going to see anything here that's going to complete it as a rectangle. So I'd look on, I would just see this L shape. So I have a couple options. I can either break it down into 2 separate rectangular prisms and then find the area of each and add it up, or because I already determined that each one of these squares is worth 1 centimeter squared, I can actually also just count 1, 2, 3, 4, 5, 6 units squared. Okay, and that takes care of my left side, but of course back here I have my right side, which is identical. So to take care of both, I can just double it. Okay, 2 times 6 gives me 12. So that takes care of both my left and my right. Okay, otherwise, if I only had the dimensions, I didn't have the square units inside of there, I could also just go this little square shape, 2 times 2 is 4. This little rectangle, 2 times 1 is 2. 4 plus 2 is 6. I'd still get to the same place. Okay, so it's not much different, but to be honest, I personally find it easier just to count up the units when it's divided this way, but whatever works best for you is fine. Okay, now finally, top and bottom. So now I have to imagine that I'm looking straight on from the top. So what would I see? Straight on from the top, I would see a rectangular face. This raised part, and then the first step down. That's what I would see. This raised part, and then this first step down. So it's just a rectangle, meaning length times width. And because my bottom is matching to my top, that means I'll double it, whatever it is. Okay, so let's take a look. That's going to be length 1, 2, 3, 4, 5 by the width 1, 2. 5 times 2 is 10. 10 times 2 is 20. Okay, so that accounts for every single face on this shape. So my last step is to add them all up. 40 plus 12 plus 20, grand total 72 centimeters squared, because we are talking about centimeter, 1 centimeter by 1 centimeter units. All right, on to B. So that was A, on to B. Okay, I'm going to start the same way. Front to back. Left, right. Top, bottom. Okay, always starting with my views. Front and back, whatever I get for the area of the front, double it to account for the back as well. Left, right, whatever I get for the left, double it to account for the right as well. And finally, whatever I get for the top, double it to account for the back as well. Again, which one you call the front, which one you call the side, doesn't matter, just don't calculate the same faces twice, the same set of faces twice. So again, I'm just going to call this darker shaded blue area my front, and then obviously the opposite side to that will be my back. So if I visualize, imagine that I'm looking straight on at this shaded region, then all I would see would be this row here, this column, this column, and this one back here, which is matching to this one. Okay, so as a flat two-dimensional view, it would just be a rectangle, meaning to calculate that, I can just use length times width. So my length would be 1, 2, 3, and then 4, right? I can count up here too. 1, 2, 3, 4 units across. My width right here, 1, 2, 3, 4 units. 4 times 4 is 16, and 16 times 2 would be 32. Okay, on to my left and right. So for me, that's going to be this face here now. So again, you have to imagine you're looking straight on that face. So you would see this column, these two, and these two. Those would be the columns that I would see. So again, looking on it as two-dimensional flat view, it would just be another rectangle. So length times width. So 2 times my length would be 1, 2, 3, 4, 5, 6 units by my width, 1, 2, 3, 4 units. 6 times 4 is 24, and 24 doubled is 48. So that takes care of the left and the right. So now finally, top and bottom. So if I imagine I'm looking straight down at the top, the two-dimensional shape that I would see is this cross shape here. So again, if I didn't have the square units right there drawn for me, then what I could do is I could break this down into multiple rectangles, and then just do length times width plus length times width plus length times width. That would work just fine. But because I have the little square units and I know each one is worth 1 centimeter square, I personally find it easiest just to count them up. 2, 4, 6, 8, 10, 12, 14, 16 centimeters squared for the top there. And then because I have an identical bottom to that, 2 times 16 would give me 32. Bring that down here. So now finally, add all three of those groupings together. 32 plus 48 plus 32 gives me 112 centimeters squared. Okay, so that's number 4 all done. Okay, so next is number 6. Okay, so number 6 says, if you build the rectangular solids and slide them together as shown, what is the area of the overlap? Okay, assume the dots are 1 centimeter across. So again, always good to start with your legend. So this time we don't have lines, we instead have a dotted grid, but again they're saying they're 1 centimeter apart. So that's 1 centimeter by 1 centimeter. Length times width, 1 times 1, so they're 1 centimeter squared each. Okay, so if we want to, we can use this information. Alright, so first thing it's asking us to figure out is what is the area of the overlap. So this rectangular prism is going to be pushed up against this one. So that means that this back face here, that's 3 units by 4 units, is going to get covered, along with that same area on this bigger prism. So we need to calculate that area and then double it to figure out the total area that's going to get covered up. Okay, so it is just a plain old rectangular face that's going to get covered. So that's just length times width. A for area equals length times width. So the length of that face is 1, 2, 3, 4 units by 1, 2, 3 units. 4 times 3 gives me 12 centimeters squared. So that accounts for just that back face there. But like I said, when we push it up, it's also going to cover that same area on this big one. So let's double that to account for that back, but also what it's covering on the big one. So 12 times 2, 24 centimeters squared. So that's what's going to be covered by the overlap. So that takes care of A. So now B asks us, what is the surface area when the solids are together? Okay, so this is not bad because really we just have 2 basic rectangular prisms. So if we just calculate the area of each and then subtract the overlap that we're going to lose when they're pushed together, then we'll have our final answer. So we've got this small rectangular prism and we've got the large rectangular prism. Okay, so small rectangular prism, large rectangular prism. So the small one will break down into front, back, left, right, top, bottom. Same thing with the large. Front, back, left, right, top, bottom. Okay, and of course, we'll add them up because we're looking for the area of them once they're attached. We just can't forget to subtract the area that we lost by pushing them together, because we're going to lose those two faces that we calculated in number 1. So we're going to lose that 24 centimeters squared. So I'm just putting it here so I don't forget about it. Okay, so anyways, keep it contained here. So for the small rectangular prism, starting with the front and then of course doubling the number that I get, and it is just going to be all rectangular faces. So all of these are just going to be 2 times the length times the width. 2 times the length times the width. Whoop. 2 times the length times the width. 2 times the length times the width. 2 times the length times the width. Okay. So this first one, front, I'm going to call this bigger face here the front. Again though, it doesn't matter what you call the front, what you call the side, as long as you're not calculating the same pair of faces twice. So I've got 1, 2, 3, 4 units by 1, 2, 3, 4, 5 units. Okay, and it did tell us that they were each a centimeter apart, so I can just count by ones. 4 times 5 is 20, and then 20 times 2 is 40. Next, left and right. So because I said this is my front, that means this right here is my left. So I've got 1, 2, 3 units by 1, 2, 3, 4 units. 3 times 4 is 12, and then 12 times 2 is 24. Next, top and bottom. Okay, top is pretty clear which one that is, and it's 1, 2, 3 units by, so 1, 2, 3 units by 1, 2, 3, 4, 5 units. 3 times 5 is 15, and then 15 doubled, or 15 times 2 is 30. Next, onto the large rectangular prism. Front, I'm going to stick with this being my front angle. So I've got 1, 2, 3, 4, 5, 6 by 1, 2, 3. 6 times 3 is 18, and then 18 doubled. Sorry, I'm having a moment here. 18 doubled. 36. Okay, so that takes care of my front and back. Left and right. So because I called this my front, that means this is my left, this big, great big face here. So it's 1, 2, 3, 4, 5, 6 units by 1, 2, 3, 4, 5, 6 units. 6 times 6 is 36. And 36 doubled, or 36 times 2, gives me 72. So last, top and bottom of my big one. That's all I've got left here. So 2 times length. 1, 2, 3, 4, 5, 6 times 1, 2, 3. Okay, 6 times 3 is 18. And again, 18 times 2, 18 doubled, is 36. So, whew, all together, $40 plus 24 plus 30 plus 36 plus 72 plus 36, 238 centimeters squared. That is not my final answer, however, because I have not yet subtracted the area that I lose when I push these two together. So like I wrote over here, the area that ends up getting covered when these two overlap is 24 centimeters squared. So I have to subtract that amount. 238 minus 24. Final answer would be 214 centimeters squared. Okay, number 7. Examine the solid and its views. All angles are right angles. What are the dimensions of the cutout piece, first of all? Okay, the dimensions of the cutout piece. So it's not asking for the area, it's just asking for the dimensions. So this, okay, so this right here is my front view. So this cutout right here is this one right here. Okay, and if I know that this little piece here is 14 centimeters, and I know the full distance is 25, then that means to find this little cutout here, I just need to subtract 25 minus 14. 25 minus 14 gives me 11. So that would be this part right here. Now this one down here, do I have that information? I know that all the way across is 35, but that's about all I have so far. Okay, so let's see what else I got here. So the top view, I know it's 18 from there to there. This might be easier if I draw out the diagram. Let's see here. And then from my right side, top view, right side, okay. So my right side is showing me that it's 9. Okay, I'm just going to draw out the cutout here. Okay, so that's the cutout. So I already figured out that this right here is 11 centimeters. Okay, and I already know, okay, I see. So this right here, okay, so this side here is this here. Okay, so this showing me that this is 9, that would run parallel to where the top of this cutout is right here. So that means that this is 9 centimeters. Okay, that also means because this runs parallel to this and this. That means this is also 9 centimeters. Okay, and because I know that this runs parallel to this and this is also 11 centimeters. Okay, so to show you what I mean, so this runs parallel to this, this, and this, so those are all the same. This runs parallel to this and this, so those are the same. So all that I have left is this, this, and this. But once I have one of those, I've got them all because they run parallel and are therefore all the same. So that's all I have left to figure out. Okay, so we know from there to there is 18. And this, so this line, we need to know what this is in order to subtract that 18 to find what this here is. So let's see if this runs parallel to something we have. Okay, that runs parallel to that here. And this front piece is right here. So 35. So that means I can do 35 minus 18 to get that last dimension that I need. So 35 minus 18 gives me 17 centimeters. So that means this is also 17 centimeters and this. So I've got all my dimensions there. This little area is 9 by 11. This little area is 11 by 17. This little area is 9 by 17. So it just asked me for the dimensions. It didn't ask me to actually calculate it. So I'm done with A. Okay, B says, explain how cutting out the corner piece will affect the surface area of the original rectangular solid. Okay, I told you guys they love this question. This was something that we did in the foldable, if you recall. I'm going to pull my foldable out here. Okay, my surface area basics. Right here. Remember, we made this arrow and we made this note. With this 3D form, the one with the corner cut out, we neither gain nor lose any surface area from the regular rectangular prism. Surface area comes out equal. Okay, so right here, that is the form we have, is the one with just the corner cut out. So explain how cutting the corner piece will affect the surface area of the original. The answer would be cutting out the corner piece does not affect the surface area of the original. Okay, and last one, number 10. It says use centimeter cubes to build the object shown. So I was obviously not expecting you to do that because I am thinking that people probably do not have those snap cubes at home. Some of you might. If you do, you can. Or if you have Legos like we do at home and you want to use those, you can. But it's fine. I'm not expecting you to build it. But what I do want you to figure out is 10A. What is the object's surface area? So first thing to note is that each of these faces is square and the dimension given to us for one side is 1 centimeter, meaning that each of these small square faces is 1 centimeter by 1 centimeter. So again, you see I'm starting with the legend. Length times width, 1 times 1 equals 1 centimeter squared. Okay, that is the area of every single one of these squares. 1 centimeter squared. So the object surface area. Just like always, let's break it down into the matching views. Front, back. Left, right. Top, bottom. I'm going to call this shaded darker blue region my front. Okay, and if I imagine looking straight on at this, I'm going to see a staircase shape. I'm not going to see a perfect rectangle. So my options are, I can break it down into 4 rectangles and go length times width plus length times width plus length times width plus length times width. Or because I have these squares, I can actually just count, which is honestly my preferred method. I find that easier. So counting up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my front face is 10 centimeters squared, and the back will be identical. So I can just double that to take care of both front and back. So that comes up to 20. Next, because I called that my front, that means my left would be the base of each of these stairs. So what would I see looking straight on? I would see this, 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 those 4 units right there. And again, because I've already counted them, I've already figured out there's 4 of them, well, that's 4 centimeters squared. So the left side, I would see a straight line of 4 square units, 4 centimeters squared. The right would be identical, so just double it to come to 8. And finally, the top, looking straight down, I would see the top of each of these stairs. And again, I end up with 1, 2, 3, 4 units. And because I also have a matching bottom piece, double it. 4 times 2 is also 8. Add it all up. 20 plus 8 plus 8, 36. I don't know why I'm putting in the calculator. I already know what it is. But if you need to use your calculator for any of this, guys, of course, you go ahead and do that. So there is the area of my little 3D staircase there. Okay guys, so that's it for this video. Thank you very much for watching. I hope that it was helpful, and I will see you in the next one. Bye!